Hi. So now that we understand what those equations describe, we know every last bit of this model. We are finally ready to find equilibrium solution to this model. However, look, as we said, this is a system of 5 simultaneous equations with 5 unknowns, so 5 endogenous variables. However, in this case, it's rather troublesome to solve the model for all the 5 variables at the same time. So let's start with something simple. Let's just say that I just wanna know what is the equilibrium income, so GDP, and consumption. Okay, so what I need to do now is to reduce this system of 3 simultaneous equations to just 2. But I need to do it in such a way that those 2 equations will contain all the information present in the entire model. So how would I do it? Look, the easiest way, for example, is to take the expression for aggregating expenditures and substitute it over here. So we get rid out of this endogenous variables. So look, out of these 2 equations, I'm just getting y equals to c plus I0 plus G0. Okay, now in the second step, what I need to do is to condense those 3 equations into one for consumption. And look, how do we do it? Okay, let's first write equation for consumption. However, now look, I know that yd is equal to y minus t. So why not write that? But this isn't enough, right? We still got a third equation, but it's also not an issue. Look, what I can do over here is to substitute t with t times y. So I got that this is a plus b times, or maybe like that, times y minus t times y, right? Over here, I could easily see that I can take y out of the brackets, right? So I'm going to get that this is a plus b times 1 minus t times y. Okay, and look, those 2 equations. So, this one and this being equal to this is enough for us to solve this system for income and consumption. So, how are we going to go about it? Look, first thing that we always do in such circumstances is of course put all exogenous variables on the right hand side and all the endogenous variables on the left hand side. Look here, endogenous is income and consumption, right? So we move them to the left hand side. So we've got that this is y minus c is equal to I0 plus G0. And over here, still y and c and y. So I'm moving expression with y to the left hand side. So I get that this is negative b times 1 minus t y plus c, and this is equal to a. And look, this is in the form that is right away ready to transform into matrix notation. So we get that this is 1 minus 1 minus b, 1 minus t, negative 1 and 1. Here we will have endogenous variables y and c, and exogenous I0 plus G0 A. Okay, so now that what we've got this into in the matrix notation, first thing we should do is to see if the equilibrium solutions exist. What do? Of course, we start by calculating the determinant. So we've got that this is 1, then minus and minus gives us plus, but we remember that when we go upstairs we've got minus up front, b times 1 minus t. Okay, and now the question is whether this is different than 0. Okay, so let's review what we know. We know that t is somewhere between 0 and 1, right? But this means that 1 minus t is always also between 0 and 1. If you take a number between 0 and 1, you subtract it from 1, you also always get a number that is between 0 and 1. What else do we know? We know that B, marginal propensity to consume, is also between 0 and 1. If I multiply a number between 0 and 1 by another number between 0 and 1, what I'm going to get is another number that is going to be between 0 and 1. I even know that it needs to be, we're going to get a number that is closer to 0 because we multiply a number between 0 and 1 by another number between 0 and 1. So the value is shrinking, just taking part of each. So now, if I'm going to take 1 and subtract from it a number that is between 0 and 1, I hope it's not going to surprise you. We are going to get a number that is between 0 and 1. So we know that the determinant here is somewhere between 0 and 1. And this is a very important result that you're going to be using very, very often in your macroeconomics class. Look, what is important to us the most at the moment is the thing that if the determinant is somewhere between 0 and 1, is definitely not equal to 0. And if determinant is definitely not equal to 0, this means that equilibrium solutions exist, and we can easily find them using Cramer's rule. Okay, so let's first find equilibrium income, right? So we need to calculate determinant AY, and what are we getting out of this? Look, first thing we need to do is to take vector of exogenous terms, replace the first column, right? So we got that this is I0 plus G0 over A times negative 1, negative 1, 1. So if I calculate this, I get this is I0 plus G0 over A plus, because A times negative 1 is 1, negative A times minus is A, so plus A. And look, equilibrium level of income is given by AY over A, which in our case, if I reverse the order a little bit here, gives us A plus I0 plus G0 divided by, of course, the determinant, 1 minus B times 1 minus t. And this is equilibrium level of income in our economy. Okay, now we can do the very same thing for consumption. So we calculate first AC. So now I replace the second column of the coefficient matrix. So I got that this is 1 minus B, 1 minus T, times I0 plus G0 over A. Yeah. So we got that this is A plus B times 1 minus T times I0 plus G0. So now what we found is autonomous. It is equilibrium consumption AC over A, which is given as A plus B times 1 minus T plus I0 plus G0, all divided by 1 minus B times 1 minus T. Okay. So, as you see, it wasn't that difficult. Now, however, we can get more out of this model. If, for example, now I want to solve this model for 3 variables. Now, I'm not only interested in income and consumption, but I also want to know what is the equilibrium level of tax revenues. So, again, I need to condense this 5 equations, this time to just 3. Okay, so how do I go about it? Okay, look, we can use what we've got here already, because this is what we don't need. We are not going to use go any further than this over here, right? Because now I still can replace yd with y minus t. However, I'm not going to rewrite it further because we would lose the last 5th equation. So the only thing I'm going to do over here is that I'm going to write that this is equal to a plus by minus b t. Okay, and this is going to be our second equation. And finally, this is going to be our third equation, t equals t. Right? So, now that we have those, again, we need to do the same trick. We put all endogenous variables on the left, all the exogenous variables on the right. So again, this expression over here transforms into y minus c equals I0 plus, okay, I'm going to write it over there, just not to avoid confusion. Y minus c equals I0 plus g0, right? Over here, we've got 3 endogenous variables. So we've got that this is minus b, y, plus c, and plus b, t equals to a. And finally, here we have only endogenous variables, so we see that negative t, y, plus t equals to 0. Okay, so now we can build, we can build this system of 3 simultaneous equations with 3 unknowns. to matrix notation. Okay, so we're gonna start with y. So we're gonna have coefficients 1, negative b, negative t. Then on c we got negative 1, 1 and 0. And on t we've got 0, b, and 1. And over here we got y, c, t. Oh, we don't know if equilibrium exists. Oh, well, if it works for just 2, it will work for all 5, because those are, this is the same system, just we are now using more of it. Okay, so we got that this is I0 plus G0, A0. Okay, and again we're starting with the determinants. Okay, what do we get? 1 plus bt, right? Plus 0 minus 0 minus 0 and minus b. Okay, but look, if I'm going to take negative b out of the parentheses here, I'm going to get 1 minus b times 1 minus t, which we, of course, remember, is always between 0 and 1, which means also that this is definitely different than 0. Okay, and it should come to you as no surprise. Look, even if we would use all 5 equations, determinant would remain the same. Okay, so what do we do next? Well, now we need to find the solutions for all the variables. So I'm starting with calculation of AY. So I replace the first column. We could do this, of course, as well with Laplace expansion, but this part we're gonna leave for the next portion. So we're gonna just calculate it step by step because it's really easy. Out of this we get I0 plus G0, and then we've got 0, 0, 0, 0, plus n. So, I hope this also comes to you as no surprise. Equilibrium level of income is exactly the same. Is A plus I0 plus G0 over 1 minus B times 1 minus T. Okay. I don't want to get into too much detail about it now, but I just want you to notice one specific thing that we're going to talk about in detail later. Look, those are all positive. Now, the number in the numerator is, in the denominator is between 0 and 1. What happens to a number when you divide it by a number that is between 0 and 1? What if I divide 10 by 0.5? Is the same as multiplying 10 by 2, right? So this is going to be 20. So this should tell us right away that equilibrium level of income is not only positive, which makes perfect sense, but it's also bigger than the sum of autonomous consumption, investment, and government spending. Why is it so? A little bit later, once we get into comparative status. go for consumption. So now we replace the second column. We've got 1 negative b negative t I0 plus G0 A0 0b1. Okay. So what do we get? A times b plus, actually minus, I'm sorry, negative t times b times I0 plus G0. Then we've got 0, 0, 0, and 1 minus b. So plus b times I0 plus G0. Okay, if I'm gonna take if I'm gonna combine, take the common part out of those two results, I'm gonna get that this is A plus B times 1 minus T I0 plus G0. Look, again, this is exactly the same result that we got previously, which should come to you as no surprise. And again, let me stress, of course, the equilibrium solution is given by AC over A, and it's equal to A plus B, 1 minus T, I0 plus G0. And it is divided here by 1 minus b times 1 minus t. Again, look, all the expressions in the numerator are positive, and because this is a positive number, we multiply it by a number between 0 and 1, we add a positive number, makes perfect sense. Okay, so finally, we can solve it for taxes. So we replace the last column now. And it is 1 minus b minus t negative 1, 1, 0. I0 plus G0, A0. Okay, so we got that. This is 0. Negative, so positive t times A. Then we've got 0, we've got plus t times I0 plus G0. We got 0 and 0. So we get, if we take common part out, that this is t times A plus I0 plus G0. Okay, let me just write this solution somewhere else. Oh, let's just say over here. Sorry, taxes. And solution here is of course AT over A. And what do we get? We get that this is T times A plus I0 plus G0 over 1 minus b times 1 minus t. Okay, again, look, this is a positive number times a fraction, it's positive. But let's look at something over here. Look, this t that we've got over here, I could just take it and put it like that. Right? Still the same expression. However, we can see now that this over here is equilibrium level of income, which we see over here, right? So, what we got is that equilibrium level of tax revenues is simply equal to T times equilibrium level of income. Which makes perfect sense, right? Given the equation that is showing us the relationship between income and tax revenues. Okay, so let's now complicate our life even more, and let's just say that we want to solve this system for 4 different things at the same time. We additionally want to know what is disposable income. Why am I not choosing aggregated expenditures? Well, aggregated expenditures are going to be equal to equilibrium level of income anyway, so doesn't matter what happens, they are equal. This wouldn't be that interesting. However, here we will get some new information. Okay, so what will be this new information? First, we need to again change what we were using here. Now, as we want to make disposable income an endogenous variable, we leave it as it is in the equation for consumption. And in this case, this equation just stays exactly the way it was. Now, this one we're also going to use, but let's move it for later. So now we need to use this equation, yd equals y minus t, and over here we finally have y equals t times y. So look, we again use information from all 5 equations. We just got rid of only one variable over here. Okay. So, again, our job is to solve this system of simultaneous equations. Okay, so what do? First, we move all the endogenous variables to the left-hand side, exogenous to the right-hand side. So we've got y minus c equals to I0 plus G0. Over here, we've got c minus b times yd equals to a. In the third equation, we've got negative y plus yd plus t equals to 0. And in the very last one, negative ty plus t equals to 0. And knowing this, we can actually now put this system into matrix notation, and of course now as we have system of 4 simultaneous equations with 4 unknowns, our job is going to be a little bit more complex, and we will have to resort to Laplace expansion to find our solutions. Okay, so what do we start with? Okay. Matrix of coefficients. Okay, so we've got 1, 0, negative 1, negative t. Then consumption. Negative 1, 1, 0, 0. Okay, then we move to the disposable income. 0, negative b, 1, 0. And finally, taxation, we've got tax revenues 0, 0, 1, 1. Okay, so we've got income, consumption, disposable income, and taxation, which is equal to I0 plus G0, A0, 0. Okay. Again, we should start by trying to calculate the determinant. Okay, so let's do it. Okay, our determinant is going to be given by is going to be calculated out of the matrix of constant terms. So we got 1, 0, negative 1, negative t. negative 1, 1, 0, 0, 0, negative b, 1, 0, 0, 0, 1, 1. Okay, we need to solve it by Laplace expansion. You haven't done it in a while, so let me just repeat how we did it. Look, in case of Laplace expansion, we choose a row or a column that has the most ones and zeros and expand the determinant by it. Okay, I'm going to choose this one because I believe this one is the easiest one. It has 2 zeros. It has 2 zeros. Although, you know what? No. Here, let's do it differently. Actually, let's try to do it this way. Actually, over the first. Oh, we're gonna do it over the first row, along the first row. Okay, so we've got first element of the first of the first row is 1. Now we multiply it by -1, and this element is located first row, first column. So we put here 1 plus 1 times the minor. So we delete first row, first column. We've got this 1 negative b 0 0 1 1 0 0 1. Then we've got plus. The next element in this row, right, is -1. And we multiply it by -1 to the power. And this element is in the first row, second column, so we've got 1 plus 2, and times the minor. So what we've got left, after deleting first row, second column. So we've got that this is 0, -1, negative t, negative b, 1, 0, and we've got 0, 1, 1. Okay, look. Of course, we could expand by another 2 elements, but because they are zeros, it's pointless. This is all we need. Now, let's look what we've got here. 1 times -1 to the power of 2, it's just 1. So we can skip it, right? The same here. -1 times -1 to the power of 3, so times -1 is 1. We can skip it. But let's see over here. Look. If I would here do Laplace expansion using the first column, what would I get? Look, this would be 1 times -1 to the power 1 plus 1, right? Because its element is in the first row, first column, times 1, 1, 0, 1. Again, this is just 1, and this determinant is also equal to 1. So what we get out of the first expression is just 1. Now, over here, the best place to do Laplace expansion would be, the best row or column would be, I think, first row, 2 zeros. So look, now we've got that this is minus b times -1 to the power 1 plus 2, which will give us just positive b, but that's in a second, times the minor, -1, negative t, 1, 1. Okay. So look, here, -1 to the power of 3 is -1, so those two minuses actually cancel each other out, and we've got plus b. However, look, out of this determinant, out of the first column, I can take -1 out. And this is what we get. So, over here, we've got that this is 1 minus b times 1 minus t. So look, we've calculated yet again that we've got exactly the same determinant. determinant in this system of simultaneous equations stay always the same, regardless of how many of those are we going to use. And it's still 1 minus b times 1 minus t, which is different than 0, because we remember that this expression is always between 0 and 1. Also, very important for you to remember this during your macroeconomics class. Okay, so what do we do next? Now we know that equilibrium solutions exist. Well, so now it is the best time to find them. Okay, so we start with AY, and AY is I0 plus G0, A0, 0. Negative 1, 1, 0, 0, 0, negative B1, 0, 0, 0, 1, 1. Okay. Here again, we can make expansion by any row or any column. Okay, let's use the same one. Here probably you know what? No, I want to choose this one now. We'll see what happens. I did never try. Okay. So, I'm getting out of this that this is I0 plus G0 times the minor. I'm ignoring the sign because there's going to be 1 over here. And we got that this is 1, 0, 0, negative B, 1, 0, 0, 1, 1. Okay, and look, plus, but of course this is going to be a minus because this is in the second row, first column. So we've got negative A times, and if I delete this, I add a second row, first column, I'm going to get negative 1, 0, 0, then nothing, then 0, 1, 1, 0, 0, 1. Okay, haven't we missed anything? No. Okay. So look, again here, if I would expand by this row, it would turn out that this entire expression is equal to 1. So this is again 1. So we know that this entire thing is equal to I0 plus G0. Here I can get rid of the minus and do the same thing. If I would expand by this row, I would get this, which is equal to 1. So this means that AY is equal to A plus I0 plus G0. And this is how we get our first result. Which again, is, I hope it doesn't come as a surprise, is exactly the same as we got into using 2 previous methods. We've got that equilibrium GDP is A plus I0 plus G0 over 1 minus B times 1 minus T. Okay, so with income out of the way, now let's move to consumption. So, our consumption, so for consumption we calculate AC, and now we replace the second column. Okay, so we got 1, 0, negative 1, negative T, I0 plus G0, A0, 0, 0, negative B1, 0, 0, 0, 1, 1. Okay, again, I'm just going to use. I'm going to use. Okay, no, this time. I'm going to use the first row. It doesn't matter, but like if you have a favorite, just you can use. Okay, so out of this we're going to have 1 times negative 1 to the power of 2. So again we're going to have a 0, 0, negative b 1, 0, 0, 1, 1. Okay, and then we will have minus I0 plus G0. And times, if I delete first row, second column, it's 0, negative 1t, negative b1, 0, 0, 1, 1. Yeah. Okay. So, how much is this? Look, again, we can expand by first row. And we're going to get that this is equal to A, by first column, I'm sorry, A times 1, 1, 0, 1, which is equal to A. Now, over here, is there a simple trick? Well, I don't think so. We just need to calculate it. So this expression over here is 0 minus bt, 0 minus bt, 0, 0, 0. Minus bt, and then the final one is 0, minus bt, 0, 0, 0, and plus, minus, minus b. Okay, I'm sorry because I forgot the minus over here. It's plus bt minus b. Now, perfect. Okay, so we get that this is A minus A minus b times 1 minus t, right? Out of this, if I'm going to take these, 1 minus t, and times I0 plus G0, which again gives us the same result as we had previously for consumption, and we get that the consumption, equilibrium level of consumption is given by AC over A, which is A plus minus A minus B times oh, of course, I'm sorry, minus and minus gives us plus, and A plus B times 1 minus t, I0 plus G0 over 1 minus B times 1 minus t. Okay, so with two variables out of the way, we're going to move actually to t now. Why we are moving to t? It will become self-explanatory once we do it. So remember, we change the direction now. We're solving for t, so we're going to replace the fourth column. So we're calculating AT. So we've got 1, 0, negative 1, negative t, negative 1, 1, 0, 0, 0, negative b, 1, 0, I0 plus G0, A0, 0. Okay, and look, in this particular case, well, definitely the last row seems like the best choice, right? because we've got here like 1, 2, 3, fourth row, first column, so negative t turns into t, right? Because this is negative t times negative 1 to the power 1 plus 4, which is 5, so we've got that this is t, and times negative 1, 1, 0, 0, negative b, 1, I0 plus G0, A0. Okay, and I hope you can see that again. We can use Laplace expansion. Again, this would be the best choice for the... This would be the best choice. Yeah, well, yeah, definitely this would be the best choice. Yeah. So, we get that this is t times element, but to the power 1, 2, 3 plus 1, 2. So we will have negative t and times negative 1, 1, I0 plus G0, A. And this is equal to, of course, negative t times negative a minus I0 plus G0, or the result we already saw upon cancellation. Of course, the minuses will give us t times a plus I0 plus G0. Okay. And this is how we get the result we had before, that t is simply equal to at over a, which is equal to t a plus I0 plus G0 over 1 minus b times 1 minus t, and this is equal to t times y, equilibrium. Okay, so finally we are ready to tackle disposable income. So now we're gonna do AYD. So we replace the third column, right? So we get that this is 1, 0, negative 1, negative t, negative 1, 1, 0, 0, I0 plus G0, A0, 0, 0, 0, 1, 1. Okay, so I'm gonna choose this row, this column, third column. So I got that this is I0 plus G0 times and 0, 1, 0, negative 1, 0, 1, and negative t, 0, 1. And then minus, of course, because the first one was with plus, so the next one needs to be with minus, a and 1, negative 1, 0, negative 1, 0, 1, negative t, 0, 1. Okay, so this time I'm choosing, of course, I'm choosing this this row. So this is giving me negative I0 plus G0 times negative 1, negative t, 1, 1. But of course, we remember that we can always take minus 1 or any other common divisor up. So we've got plus. And look, here we're using the second, in this case we are going to use second column, right? And so we've got that this is negative a times negative 1, which will give us plus 1, but then, because this is a second element, it's in the first row, second column, it would be negative, so we've got minus again, and we've got, again, negative 1, negative t, 1, 1. Okay, and here, I can give plus. Okay, as you see, those two are identical, right? So we can take what we've got here out of the parenthesis, yeah, and we would have here 1, 1, t, 1. Right? However, this is really easy to calculate, that this expression is simply 1 minus t. Okay, and this gives us one thing we were missing over here, which is disposable income. Okay, so the disposable income that we got over here is given, this equilibrium disposable income is given by 1 minus t, a plus I0 plus G0 over 1 minus b times 1 minus t. However, look, what will happen if I'm going to split this expression into two separate ones? Right? If I'm going to first multiply everything by 1, I'm going to get that this is a plus I0 plus G0 times 1 minus b times 1 minus t and minus t times a plus I0 plus G0 over 1 minus b times 1 minus t. However, we have seen those somewhere already. Look, this is nothing more than an expression for equilibrium level of income. Here we've got minus t times equilibrium level of income. But t times equilibrium level of income is also equal to equilibrium level of tax revenues, which makes perfect sense when you think about it even for a second. Okay, so look, we've calculated exactly the same model in 3 different ways. The main thing I want you to remember from that is that actually, depending on what you mean, you can always manipulate the model a little bit to get out of it what you need. Because look, some of those things you see we can calculate easier. Instead of doing this, all 4 of those, what could we do? Like t times equilibrium level of income, t times equilibrium level of income gives us equilibrium level of taxation. So equilibrium level of taxation we actually could just take from the first case when we just were calculating income and consumption. And the same disposable income, equilibrium level of disposable income. Knowing the first 2, we've got the second. But look, sometimes when you deal with the model, you do not know what is going to be important. So what you need to try to always figure out is what is important and what is the best way to get it. I'm just showing you options. And as you see, regardless of how we calculate it, we always end up in the same situation. Okay, so this is it about national income model for the closed economy. Since next video, we're gonna start open economy. Take care.